हाय मैं हूँ डोरा। हाय मैं हूँ ईशान और आज हम बनाएंगे एक पावर सप्लाई। लेट्स गेट स्टार्टेड। Wait, are you also looking for budget-friendly 3D printing for your next project? Don't worry, I've got you covered. Just check out the link in the description below and you'll thank me later. I found this really cool power supply in Bamboo Lab Maker World. Just have a look at it. It looks so cool and I plan on 3D printing it. Just have a look at it. It looks so fucking cool. I have slightly different components. I'll be using them. Let's 3D print this beast. So I've finally got all the 3D printed parts. I have printed all the parts for the power supply. I have got the components as well. Let's have a look. This right here is a XL4016 buck converter. This powerful beast is a 200 fucking watts buck converter. Yani ki this buck converter has an efficiency of about 94%. Input voltage ranges from 4 to 40 volts DC. Output voltage 1.25 to 36 volt. Input power is approx 200 watt and the output current is 8 ampere max. If provided enough cooling, it can go up to 10 amperes. This is super cheap. You can get it online for $200. I've completed the connection this time to test the circuit. Let's have a look. I'll be powering this circuit with the help of this Lenovo adapter. I have an old laptop, so I'm using its adapter. It is a 20 volt 3 ampere adapter, and let's see if it works or not. 7 volts. Then we have 9.2 volts. We have 12 volts, 12.5, 13 volts, we have 17 volts, and the most we have 20 volts. And we also have another potentiometer. It is for adjusting the current. So when we'll have the load, we can adjust the current as well. Now I have made the necessary changes to the power supply and guess what? पहले मैंने लगाया था उसके ऊपर एक बैटरी वाला सिस्टम जो उतना अच्छा नहीं लगा. तो I decided why not? Let's add a voltmeter and an ammeter to it. Let's test this device to its limit and let's see if this thing can be marketed as a product. 1.2 volts is the minimum voltage that we can give to any load on this power supply unit. If we increase the voltage, you can observe that the speed of motor is increasing. Gradually, we can increase the voltage in this manner. I don't know if you can see it or not, but I am controlling the voltage with my middle finger right here. Yeah, that's some sort of multitasking. Now let's observe that the speed of motor has increased since I'm increasing the voltage. Right now the voltage is approximately 10 volts and the current right now that motor is pulling is 0.1 ampere. Now let us test the current this power supply can give us, and current is totally depending upon the motor. Notice the change in the current readings of this motor. Current spiked up to 240 milliamperes when I pressurize the motor to stop. Hence, the voltage remained constant at 10.4 volts. Let us increase it to the motor's full potential, which is 12 volts. Approximately 12.5 volts, and the current right now the motor is pulling constantly is 100 milliamperes. Approximately 400 milliamps of current. Approximately 400 milliamps of current, that is what the motor was made for. It was a 150 RPM with a 2-stage reduction. And just imagine that you can plug in any adapter to this power supply. This power supply has a limitation of 1.2 to 35 volts. That means can be varied in a very wide spectrum of voltage. Even the current, it can handle up to 8 amps of current, as I mentioned earlier. Do check out this power supply, and if you find this video useful, subscribe for more. This is TheIshanJain signing out.